Today we will be reviewing the previous exam. Number one, we're talking about this function and then we're talking about its derivative. Now, but notice this is in fact a function that has the absolute value. And then the point which we are looking at is when x equals 3. Now, one graphical way which we can approach this one is if you have to sketch this using your graphing calculator or any other way you like to, you will realize that when x equals 3, you will see a corner. So whenever you see a corner, you will realize that the function is not differentiable. Hence, the answer will be non-existent. Now, but if you wanted to look at more algebraic approach, it would have been something like this. The fact that we are looking for derivative. This we're talking about the limit as h approaches 0 for f of x plus h minus f of x all over h. Now, but the thing is, in this particular case, since this is the absolute value function, we will realize something like this. Limit, we'll just call this whole expression, why don't we call this whole expression as one box, for example, so that it will be easier for us to express. Limit of that box as h is approaching 0 from the right. That basically means we are approaching 3 from the right side. Then in this particular case, we will realize that f prime of x will simply become, this portion becomes 2 at 0, and then this portion also becomes 0, hence we end up getting 1. But on the other hand, if you wanted to approach the limit of the same box as h approaches 0 from the left side, then we are looking into this portion. And in that particular case, f prime of 1 will be equal to, in fact, -1. You see the derivative will not be equal to each other, hence we're not able to find the derivative when x equals 3. Now, number 2. In this case, once again, we are looking for tangent to the graph. Now, as soon as we're looking for tangent to the graph, we'll be looking at 3 things: slope and the point. Now, point we know because it mentioned the origin. We just need to find out the slope. How are we going to find the slope? We will just have to find out the y prime. What is the y prime in this case? It will simply be 1 over square root of 1 minus x over 2 squared. And then by the chain rule, we have to multiply it by the derivative of x over 2, which is simply equal to 1/2. Now, but since it's origin, then x has to be equal to 0. Then, at 0, 0, you will realize that y prime simply becomes, this portion becomes 0, hence this whole thing becomes 1, which leaves 1/2 as our slope. Now, since it's passing the origin, our equation would have been this: y equals 1/2 x. But you will realize that this will be only equal to choice A. Hence, choice A is our answer. Now, number 3. We mentioned that this is tangent to the tangent in the first quadrant to this curve. Now, tangent, in fact, has 2 components to it, which is slope from here. Slope 1 is equal to slope 2. Not only that, the point x1, y1, in fact, will be exactly the same point as x2 as the y2. So let us try to look into this one together. Now, in fact, those two has to be exactly the same point. Now, first, when we're trying to look at the slopes, let us try to evaluate this one first. The slope here becomes Simply by solving for y, you will realize that that's equal to y equals 3x over 4, meaning the slope has to be equal to 3/4. Now, but on the other hand, when you look at this cubic function, the y prime, which gives us a slope, would have been equal to 3x squared. Now, by setting them equal to each other, you will realize that x squared must be equal to 1/4. In other words, x must be equal to plus or minus 1/2. But notice we are looking at the first quadrant. That means x has to be equal to positive 1/2, not the negative. Now, since we know the value of x, then we just have to find the value of y. In order for us to find the value of y, we can find it from here, or either way here. You will realize that y then is equal to 3 over 4 times 1/2, which later we can find out to be 3 over 8. Now, since this point 1/2 comma 3/8 is not only the point here, the linear function, but also in the cubic function because they are tangent. They share the point. Now that means 3 over 8 is equal to 1/2 to the third power plus k. Now here you will realize that this is equal to 1/8, which makes k to be equal to 2/8. Then we realize that our final answer should be 1 over 4. Hence, this would have been our final answer. All right, let us move on. Now here in this case, we just have to find the derivative of arcs, and we did something very similar to this one, which would have been 1 over square root of 1 minus 2x squared. Now that is the beginning. And then by the chain rule of that, we have to multiply that by 2. But when you simplify this one, you will easily realize that the answer would have been choice B. All right, let us move on to number 5. Now in this case, this is the position function. What is the acceleration? So let us try to find the acceleration. S prime, we know that to be equal to velocity, then here is equal to 2t plus 4. Now, in order for us to get to the acceleration, we have to find the double derivative, which will be equal to acceleration. Then it's equal to 2. Wait a minute. This simply means no matter what t is, acceleration will always be 2. In other words, this will be our answer. All right, number 6. Now, as you can see from here, we are looking at the definition of derivative. Now here we realize that f prime of x must be equal to limit as h approaches 0 for the function f of x plus h minus f of x all over h. Now since f of x here becomes e to the x, then this must mean e to the x plus h minus e to the x over h. Whoops, I forgot to write. For the limit as h approaches 0. Now, then in this particular setting, we're not just looking at f prime of x, but we are looking for f prime of e. That means, you see this x value? And this one? Those has to be replaced with value e. Then we will realize that our answer will be choice E. So, all right, let us move on. Number 7. Now, which one of them is continuous? In fact, we easily could see that exponential functions are always continuous. So is power function, except one thing, that is tangent function will not be continuous, especially for pi over 2 and at many other points afterwards by the difference of pi. Hence, the answer becomes choice 1 and choice 2. Now, let us look at number 8. If I were to rewrite that, then it becomes this limit as x approaches 0. Now, sine is on top, x is on top. What is cosecant? Cosecant is the reciprocal of sine. Now we realize that uh, limit as x approaches 0 for sine of x over x, we know this one to be equal to 1. That means this is a reciprocal of that, which will still be equal to 1. Therefore, our answer becomes choice 8. Choice D. All right. Now, here comes number 9. What is the area when the area of the square unit is expanding? The word expanding refers to motion, the first derivative. Now, is increasing twice as fast as its radius in the linear unit. Then, in other words, dA dt is 2 times of dr dt. That's what they're referring to. Then what is the radius? That becomes our final question. So if I had to draw the diagram, it would have been something like this. I have circle, and this is radius, and it is expanding. Somehow. Now, then, the equation that which we can use for the area and then the radius would have been area is equal to pi r squared. In other words, dA dt would be equal to 2 pi r by the power rule, but by the chain rule we realize dr dt. But do you remember that we mentioned that dA dt is equal to in fact 2 times of dr dt? Hence, if you plug that in here, then we will end up getting this 2 times dr dt, which is equal to 2 pi r times dr dt. Now here we can easily see that 2 would have been cancelled out right away, and dr dt also cancels out. But here notice it doesn't become 0, but rather it becomes 1 equals pi r. Hence r becomes 1 over pi. That becomes our final answer. And we'll continue in part 2.